All right, our last section for chapter 2 is section 2.4. This is a section that kind of ties it all together, brings together all the pieces and makes the case essentially for the application that we're going to be seeing our Venn diagrams used for. So this is titled Surveys and Cardinal Numbers, and our leading idea is the following. So when we use surveys and represent the results with Venn diagrams, we're analyzing how people's responses overlap. In the same way, faith in God encourages us to think about how different areas of life are connected. And I talked to you already about how crazy connections, right, with Venn diagrams happen in my life this week. Connections like this happen all the time. Belief, values, choices, relationships. Just as Venn diagrams show intersections, faith can be seen as something that overlaps with every part of life. Faith in God should inform how we live to see a fuller picture. So the first thing we're going to look at is called a cardinal number formula. This tells us how we can find the number of items in a union. It tells us a little more than that, but that's how it's defined. The number of items in A union B is the number of items in A plus the number of items in B. And then it says it's minus the number of items in the intersection. And I want to justify for you why that's true. And I'm going to do that with a Venn diagram because it works nicely. So we're going to do just two overlapping circles because it's just got circles A and B. In our union. That should end up closed, but nonetheless. All right, so if I were shading in circle A, right, everything in circle A, it would look like this. I'd include the overlap in the middle. It would get shaded in that yellow, right? This would be all of circle A. So everything that's inside of circle A would get counted if I did that when I counted things in yellow. Then it says, perhaps, that I want to count all the things in circle B. So let's shade those in, see if my pink is strong enough color to difference so you can see it. I think so. This would be everything in B, everything pink. What do you notice happened when I did that? The colors overlapped, right? The part in the middle, if I'd drawn it a little bit bigger, it'd be easier to see, but the part in the middle got shaded twice, right? It means it got double counted. That region got double shaded. So what you see happen here at the end is removing one of those shadings. I removed the overlap. That's why it's subtraction off at the end. I'm removing the overlap. All right, so when we're given a picture like this, we don't much need the formula to do this, okay? We're going to use the formula here in a moment. But let's take a look at this picture, and we're doing some counting from the picture. We can directly count some of these objects in this picture, or I just identify them the way that it's described. So as we're taking a look at this picture, it says that we want to have the number of items that are in A intersect B. So where is A intersect B on this diagram? It's 6. Now, these numbers are no longer representing regions like we represented them before. It's not just 1, 2, 3, 4. These are representing like a survey was taken and 6 people said the thing that's happening, whatever's in the middle, okay? So these numbers are actually representing responses from a survey, okay? So they're representing something slightly different, but we work with them the same way. That's not any different. So A union B means that I'm going to have everything inside of the circles A and B combined together. And because they're delineated and I can see each of the individual pieces, I can actually find the union by simply adding up each of the individual pieces as well. Does that make sense? This is not like the first example, like my notes at the top. We'll get back to that in a second. But I can see them all spaced out, specifically. And so I simply would add them together. So this is 3 plus 6 plus 2, which is what? That's 11. So I have 11 here. So we're going to attempt to reason through these this time. It's small enough we can probably manage it, so we're going to do that. This wants to know the number of items, right, in the complement of A. So it means it's outside of circle A, but it's also inside circle B. Say it again, Jeremiah. 2. It is 2. So it's this number out here. So it's not in circle A, so it's not the 3 and the 6. but it is in circle B, so it's the number 2. Is that good? All right. The next one is the reverse. It wants us to be inside of circle A and, right, common to, not inside of circle B. So I can't be inside of circle B now, but I'm supposed to be inside of circle A. What number do you see there? That one's 3. And then the last one wants us to be not in circle A and not in circle B.
7.
That's the 7.
So why isn't 7 counted in C and B?
Because it's actually, so on C, for example, it includes being inside circle B, and 7's not inside of circle B.
Okay.
Yeah, if it were only looking at the things on outside of A, it would be, but it's not inside of B, which is also part of the description. Yes, sir.
Whenever we see these questions, are we always going to add the numbers?
For that, like the union one, yep, you would. We'll see one real quickly so you can see the difference between ones where we don't do it that way. Okay, any other questions for this one before I switch slides? Uh-huh. Yep, there will be questions like these. Some various, some different varieties of things too. But yeah, they'll be like these.
Wait, one more question.
Yep.
Sorry.
You're okay.
So, if it was the intersection instead, if there were still multiple numbers, would you still add them?
For intersection usually means it has to be overlap, right?
Mm-hmm.
So you don't usually end up overlapping and adding unless you have 3 circles, which we don't have a picture of right now. When we do a picture of 3 circles, you'll see it, and there will be some addition on that one. Yeah. Okay, anything else on this one? All right. This one actually says, make use of an appropriate formula, and we don't have very many formulas. In fact, there's only one so far in this section, right? So we're going to make use of a formula to find a value. The formula that we have, I'll write it on the screen as well, said the following. The number of items in A union B is the number of items in A plus the number of items in B minus the number of items in the intersection of A and B. Now, I want you to pause and look at this carefully. There's 4 things we're adding and subtracting here, right? There's 4 different locations. They're all 4 different things. Agreed? What that means is that they could give you any of the 3 and ask you to find the 4th. Right? They don't have to only ask you to find what's on the left. They could give you 2 of the items on the right and the item on the left and ask you to find the missing one that's on the right as well. So pay attention to the pieces that you're given and make sure you're looking at them in the right space, right? That you're not just putting everything on the right because I thought the example that I'm doing right now does have everything on the right. But that doesn't have to be given to you as all the pieces that are on the right-hand side. So we're going to make sure that we put them in the right places. So this one says the number of items in set A is 8. That's this one. And then it says the number of items in set B is 14. That's this one, and there is an addition sign between them. And then it says the number of items in the intersection is 5. That's this one, and there's a subtraction sign before it. The 3 pieces they gave us in this problem are all on the right, and we can find the number in the union that we're asked to find on the left. So now we're going to add 8 plus 14, which is 22, and 22 minus 5, 17. So the number of items in A union B is 17. So again, why are we subtracting it out? Because this 5 in the intersection is a part of the number 8, and it's part of the number 14. Now, while this problem doesn't actually ask me to do this, I'm going to draw you the Venn diagram so you can see how the Venn diagram looks different than these numbers. The numbers 8 and 14 are not going to be on this Venn diagram. Let me show you. Okay, I keep clicking on the right button, but it's not. All right, there we go. I've got 2 circles that overlap, A and B. Now, I'm not going to be able to fill in the entire diagram. I don't have enough information. I'm only going to be able to fill in the parts that are inside the circles on this particular one because of what I'm given, okay? So this is an incomplete diagram, but I still need you to see that you're not going to have an 8 and a 14. The 5, the intersection, is right here. Okay? That's the intersection value. It's a very specific location on the diagram. The 8, however, means everything inside of circle A. That includes the 5. So how much more do I need out here in order for the whole circle to add to 8? 3. There is no 8 on this diagram. Also, the circle B, the entire circle B is supposed to be 14. But 5 of them are already accounted for in the middle. There's 9 more than that I need out here, right? For us to have the 14. Now, take a second. What happens when I add 3 plus 5 plus 9? You get 17, which is exactly what it told us over here on the outside. Okay? All right, we're going to do more of that. This is just me showing it to you on this one. Yes, Jeremiah? I took 8 minus 5. Same thing for the 14. Or the 9. I got 14 minus 5 to get my 9. Okay, so let's actually take a look at a three circle one. Yes, David? Yep. All right. So I know there's 3 circles. Why? There's 3 letters listed, right? 3 letters listed. So we're going to draw a rectangle that's got 3 circles in it, all of them overlapping. A, B, C, and here's my U. Now, one of the things that we just learned in the last picture is that when they tell us things like at the very beginning that says the number of items in A is 24, it means the entire circle A is 24. That means the outer piece here and the 3 overlapping pieces here all add up to 24. So I don't want to start filling in this diagram with the number 24 because I don't know how to split up the 24 appropriately yet. Does that make sense? And the same problem is going to happen with the n of B being 24 and n of C being 26. None of those places are good places to start this diagram. Okay? I actually still have a problem with the second line of here on here too. This says n of A intersect B is 10. Well, where do A and B intersect? Well, right here, right? There's 2 pieces, this 2 football-shaped piece, right? These 2 pieces create the number 10 when they get combined. That's not as bad as the 4 pieces making up 24, but there's still lots of options, right? I got 10 and 0, I got 9 and 1, I got 4 and 5, and 4 and 6, I've got 5 and 5, I've got lots of options. I don't want to start there either. The same problem happens with the B intersects C and the A intersects C. All of those have 2 spaces where it's referring to on the picture. The next one's the one I want. It says I want where A intersects B intersects C. Where is that? That's in the very middle of the thing, right? They're all 3 overlapping. There's only 1 space that has that description. And my number is 6. So we're going to put the number 6 right here in the middle. It's where they all overlap. And as I do that, I'm going to mark through the one that we just used so that we know that we're done with that piece of information. Now, the last piece of information in the list tells you n of U is 50. That is not telling you that there's 50 on the outside. That's telling you that all the pieces, and there's 8 of them, add up to 50. Okay? So that's like the worst case scenario. We definitely aren't starting there. Cool? Okay. Now, we've filled in that very middle piece with a 6, which means that we can actually go out just a little bit from there now, and we can fill in some other pieces. So when we looked at this A intersect B, we talked about the fact that it overlapped the top part of this circle, where they overlap, with the middle. And that whole thing is 10, but now I know that part of it, the one in the very middle, is 6. How much more do I need to put in the top now?
4.
That's 4. So there's a 4 right there. Okay, everybody good? We've taken care of that piece. The next one says that B intersects C. So B intersects C in this football that's on the right. This one actually, because of its orientation, looks like a fish to me. It's okay. there's a 6 in the middle, and I have this outer piece, and they have to add up to 8. I need 2 more. So there's 2 right here. So this piece is a 2. This should still feel a little puzzle-like. Is it? A little puzzle-like. We still haven't gotten to the actual applications. We're close. We're so close. The last one on this list says A, in this line of the list, says A intersects C. So that's the other overlapping region over here. It's supposed to be 15. 6 are in the middle. How much goes out here? 9. Now, a couple of comments that I want to make here. Clearly, the numbers have to be positive. If you get a negative, there's an error you made somewhere. Shouldn't be getting in negatives. The numbers could be 0, though, right? You could have 0, a survey where nobody answers something kind of thing, right? So if you get a 0, that's not a red flag. If you get a negative, it's a red flag. Okay, so we have done all 3 in the middle now. I still don't want to do the n of u equal 50 because that's still all the pieces that I don't know, and there's still 4 of them I don't know. But if I go back to the very first piece of information now about circle A, circle A is now mostly filled in. It's got a 9, a 6, and a 4 in it already. So how much is already in circle A? 19. There's 19 that are already accounted for. It's supposed to be 24, so how many more do I need? 5. So there will be a 5 in the outer region here. Okay? How about circle B? Well, it's also supposed to be 24. How much is already accounted for with the 4, 6, and 2? 12. So how much is missing? 12. The circle C down here at the bottom has a 9, 6, and 2. How much is accounted for? 17. And it's supposed to be 26. So how much is missing? 9. There's only one place where I don't have a number now. It's this outside piece, right? So everything in the diagram is supposed to add up to 50. How much does it currently add up to?
47.
It is. It's 47. Some of you were checking ahead of me, I'm pretty sure. I don't think you did that right when I asked the question. So that's good. It's 47 right now, right? 47 is accounted for. It's supposed to be a total of 50. So how much goes in the outer? 3. Let me make a comment that's sort of uncomfortable. If you make one mistake finding one region, what happens to the rest of your work? It's going to be wrong, right? So be careful. If you have extra time, work the problem a second time. From the beginning, make sure that you don't have anything that's going on wrong. Yes, sir.
So to find all the numbers, if you add up all the numbers that are in the circle.
And take it away from the total that it told you. So like 24 was the total it told me. And at the point when I made that decision, I added up the 3 pieces I already had and figured out how much was missing. Okay?
How did you find you can?
I added up, well, I didn't, but everybody that commented, they added up all the numbers that we already had in the whole diagram so far, which was 47, and subtracted it from 50. And then that gave me the 3 that was in the outer part. Okay, so let's see an actual example, like with actual context. You ready? Okay, so you're going to have your own examples. But I've got a couple of them in here. I think it's 2. Is that right? 2? Yes. Okay. Use Venn diagrams to work the problem. And in fact, I will tell you that sometimes they don't even have you create the diagram. If I'm remembering right, they're just going to have you answer the questions. But if you don't create the diagram, you're not going to be able to answer the questions. Okay, so whether they ask you to show the diagram or not, you need to do it with the diagram. So it says, Joe Long writes and produces albums for musicians. Last year, he worked on 10 such projects. He wrote and produced 2 projects. He wrote a total of 5 projects, and he produced a total of 7 projects. So the first decision that you have to make is how many circles are you going to need to represent this scenario? 2. How do you know? Yeah, you look at the way that they're describing things and figure out how many descriptions there are, right? There are 2 descriptions here. What are the descriptions? No. Writes and produces, yeah. The 2 descriptions are the fact that he writes some of the work and he produces some of the work. Now, I'm not even going to call them A and B. I'm going to actually label them what they are because I have categories that can be labeled. I can still label the outside as circle, of the rectangle rather, as U. That's helpful because I'm still going to need to fill in all the numbers in all 4 regions to be able to complete the diagram, right? Okay, which of these three pieces of information should we start with? The wrote and produced, which happens to be the first one listed, right? It says he wrote and produced 2. Where does that go on the diagram? The very center. Okay, pretty good so far. Okay, so we've taken care of this piece of information. The next one says he wrote a total of 5 projects. What does that mean for my diagram? Okay, so it means that everything in circle wrote, the one that says wrote, has to combine to be 5. How many do we already have in that circle? 2. So how many more do I need? 3. So there's 3 out here in the circle. All right, we took care of this one. Now it says he produced 7. So what number will I put where? A 5 out here. Okay? The entire circle produced is now 7, which is what it's supposed to be. And I still need a number in the outside region. What's that number going to be, though?
0.
It's actually going to be 0. How'd you know? Because everything already adds to 10, right? And I already told you 0 is fine. It just means that these are the only 2 things he worked on and he did when he was actually being a part of this process, right? So are there other things that he could have done? Potentially, but he didn't do any of that. So there's 0 in that outside region. Okay? In order to actually answer the questions, which are on the bottom of your page, but on the next slide that I have over here, we have to create the diagram. Okay? Let me see. I'm practicing. We'll see if I can get this transferred to the other slide. I'm learning still, and I got it. It's exciting. Okay, here's my picture. From the picture, we have to answer the questions. The first question says, how many projects did he write but not produce?
3.
That is 3. It's the outside region of the right circle. How many projects, I don't think I got my 0 in there. How many projects did he produce but not write? That was 5. And how many projects did he not write or produce?
0.
That's 0. Answering the questions is very straightforward after you've created the diagram. Okay? That's not the hard part. I mean, that's not the time-consuming part. It's not the part that's going to actually require you to do anything. It's just going to require you to look at your diagram. Okay, one more example. At a university, University of Louisiana, half of the 48 math majors are receiving federal financial aid as follows. 5 had Pell Grants, 14 were in college work study, 4 had a TOPS scholarship, 2 had TOPS scholarships and were in work study, and those with Pell Grants had no other financial aid. So I need 3 circles. That's our first question, is how many circles do I need? Okay, so I don't even have space to draw it on that slide to start with, so I'm going to flip over here and we're going to flip back and forth for a little while. I need 3 overlapping circles. What will my circles be labeled?
Work study.
Okay, so this is my abbreviation so that I can make sure they're all on there. I've got Pell, I've got WS for work study, and I've got TOPS, and then I've got our universal set on the outside. Okay, so what piece of information, we've got a couple of places we could start. What piece of information would you like to start with?
House scholarships and work study.
Say it again. What was it?
Scholarships and work study.
The top scholarships and work study, this piece right here.
Yeah.
Okay, so let's take a look at that. So top scholarships and work study. So TOPS scholarships and work study would be both this piece and this piece, which means there's 2 pieces that I have to distinguish between. So we're not going to start there, but we'll get there very quickly. Any other thoughts? Pell Grants. What about Pell Grants? Like the 5 that have Pell Grants, or the bottom part that says those with Pell Grants had no other financial aid? The bottom one. The bottom one's actually very helpful. What is the bottom one actually telling us? There's a bunch of zeros here, right? It tells us if they have Pell Grants, they do not have any other financial aid. So the Pell Grants, places where it overlaps with things, are all zeros. y'all catch that? Pell Grants did not receive anything else. So we were able to take this piece and take care of it. Now we can actually go back to what, is it Jonathan? Is that right? What Jonathan suggested if we'd like. We can actually do the two that have top scholarships in work study. Because the top scholarship in work study have a 0 in the middle now. And there would be 2 more right here, right? So we can do that one. So 4 had TOPS scholarships. So that one's down here for 2, right? 2 left on that one. So 2 and 2. So I've got 4 in the TOPS circle.
5 had Pell Grants.
Okay, 5 had Pell Grants. There's only one place for Pell Grants. That's 5 right here. All right, and then we've got 14 in college work study. There's already 2 in the outer, like, overlapping piece. So I need 12 more. 12 more, right? Yeah, 12 more here. Like this. Perfect. All right, what have I not done yet? The universal set. So there's no number in the outside region. How am I going to figure out the number in the outside region? Close. We are going to have to add it all together. So let's add it all together first. What's the sum in everything? The sum so far. How many is there? 21? Is it right? 21? Okay, 21. So why am I not going to subtract it from 48? Because it says half of the 48. So the other half may have other kinds of scholarships, but they don't have federal aid, right? They don't have federal aid. So what is half of the 48? 24. So instead of subtracting it off of the 48, I'm going to subtract it off the 24, which leaves me with 3. So there's 3 folks outside in the outer region out here. Okay? We work carefully and diligently to get the numbers in the right place so that when we get to the questions, they're easy to answer. How many had no federal aid? Nope. 24. Why is it 24? It's the other half of the 48 that didn't get put in the picture, right? It's not really a trick question, but we do have to be careful that we're not just looking at the pieces of the diagram that went in. There was a piece that we didn't put into the diagram at all, and it's the 24. There are 24 that did not have any federal aid. Okay, how many had more than one type of aid? Just the 2. Now, that happens to be the 2 right here, but what if there had not been zeros in the other place? Well, we'd add it to that 2, right? We'd add up all the overlapping pieces. How many had federal aid other than these 3 types? Yeah, that's the 3 that's in the outer region that we wanted to say on the first part of the problem. And is there a question? You're good? You got it. Okay, no problem. And then how many had TOPS scholarship or work study? So what happens when we have the word or? Yeah, we're combining pieces together, right? So which pieces are we combining with this question of the or here? The 2 and the 12 and another 2. We actually have to combine everything that's in work study, which is the 12 and the 2, and then everything in the TOPS, which would be 2 more here at the bottom. So what's 12, 2, and 2? 16. So there are 16 who had TOPS scholarship or work study. Questions on that? Yes, ma'am.
Why would we add the 2 since it says or? If it said and or, I would understand putting the second 2.
Yeah,
But
so
it
that's
just says or.
so you're asking kind of why I'm including this 2 here, actually. So that's a good question, and that's something that we kind of glossed over before. So in mathematics, we use what's called an inclusive or. So when you see the word or, it means both. Yes, so you get the parts where they overlap as well. Very important point to figure out and to mention here. Thank you for that question. Any other questions? All right.